Hello, ladies and gentlemen. I hope you're all doing well. In this video, we're looking at question 22 on our grade 7 Gauss paper. Each of the integers 334 and 419 has digits whose product is 36. And that's true. How many three-digit positive integers have digits whose product is 36? Okay, so we see if we use the 3, 3, and the 4, we make 36. If we use the 4, 1, and the 9, we get 36 there as well. So what can we do? And we're looking for different integers. So just because we know that 334, 3 times 3 times 4 is 36, you could rearrange that to be 343 or 433. Similarly, we can take 419. We can rearrange this 6 ways. You get 6 numbers just from knowing 1, 4, and 9 can multiply to make 36. Okay? So you can list them all out. Okay? Or you can sort of, this is some slightly more advanced math where you can sort of count the number of possible rearrangements for things. But I think it's probably easiest just to write out 6 possibilities here. And we get 3 possibilities up here. And then you might say, well, there's 3 numbers here and 3 numbers here. Why can you rearrange? Well, some of these numbers are the same. So if I swap these 2 3s, I still get 334. That's why we get less possibilities here. And if for some reason we had 3 numbers that were all the same, there's not really any rearranging that can be done. Now, of course, 36 is not a cube, so you're never going to get 3 numbers that are the same. All right, so we know when we get numbers that we could rearrange them to get other 3-digit numbers. This is probably important. I can see already I've got 9 different possible numbers that would work. Of course, the lowest one we've got here is 12. The most we've got is 24, so we have a bit more searching to do. How are we going to find the numbers that we seek? Well, we've got to use 3 numbers, but they have to be single digits. So at lowest they can be 1, and at most they can be 9. So even though, 12 times 3 times 1 makes 36, 12 is not a single digit, so we can't do something like that. At least not working in decimal. Okay? It'd be interesting to change the number system and see how this question could be answered. But, what are we doing here? Okay, so how do you make 36? Well, let's just take possible single factors. In fact, I think I might make a little chart here. So we could have maybe A, B, and C. And maybe A is a 1, and then that leaves 36 over 1 is 36. Okay, and then, well, what could B be? Well, we could try 2. But what's going to be left over? What would C have to be? If I've got 1 and 2, C is going to have to be 18. Well, that can't happen. Maybe B is 3 or 4. Actually, I never really checked B as 1, but that would have been 36, and that still wouldn't have worked. But we can get, so 3 would be 12. 4, 9. That does give us an answer. We've had... we listed 1, 4, 9 as one of the possibilities already. 5's not a factor of 36. 6 is. And what'll be left over, C will have to be 6. So we can sort of add to this list of, all right, 1, 6, and 6, or 6, 1, 6, or 6, 6, 1. There's 3 different places the 1 can go, and everything else is 3. So that's 3 more possibilities. 7 is not a factor of 36, and neither is 8, but 9 is, and that would leave us with a 4. Well, again, we've already sort of dealt with this one, so we don't need to worry about it. Okay. So the lowest number being 1, you're going to either get one of these 3 or one of these 6. Okay, so right now we're looking at 12 possible answers. What if the lowest number I had is 2? All right, so what's left over if We've got a 2. We've got 18 left over, so we need to make 18 with digits B and C. Okay. Well, I'm not going to use a 1 again. That's not going to work. I'm saying that I'm going to say A is the lower of the numbers. Okay. But maybe B is 2, and that would leave C for 9. So 229 along with 292 and 922. That's 3 more possibilities. Or maybe B is 3. That leaves 6. Maybe C could be 6, and then we've got 2, 3, 6, and that'll lead to 6 different possibilities. Okay, so there's 6 more. So now we're looking at 21. Now, I said the most that were possible was 24 over here. We've definitely ruled out 15, 18, and 12. We could, if somebody called time, we could take a guess at this point. But we can keep hunting. Maybe there's another possibility. So B could be 3. Could B be 4? Well, no, 4 isn't a factor of 18. Same with 5. If we use 6, we'll just get 3, and we've already done that. 7, 8, 9 would give us a 2 again. So, okay, nothing else to work there. Okay. What if A were 3? Well, that would leave 12 for us to work with. B would have to be a factor of 12. B could be something like 3. And C would have to be 4, except we've handled that case before. C could be 4, or B could be 4 and C could be 3, and that's not really going to work. 6 and 2, already dealt with that one. Right, these ones here, no sense counting them again. And 7, 8, and 9, these are not factors of 12. Okay, maybe A is 4. What does that leave? 9. So B has to be at least 4. Well, B would have to be 9 and C would have to be 1. Right? Because we've already dealt with the case where B is 1 and A is 4 and 9. We've done 4, 1, 9. 5 is not a factor of 36. 6 is. B would be 6 and then C would be 1. Well, we've dealt with that one. Okay. 7, 8, no, these aren't factors of 36. 9 is, then we'd be left over with 4, and B would have to be 4 or 1 or 2 or 2, and we've already dealt with those cases. So it looks like 21 is it. We just sort of listed them out, did it all by exhaustion. Okay, so A is going to be our answer. That's all there is to it. And that's question number 22. Up next, we're going to take a look, of course, at question 23. I'll see you for that shortly.